All right, class. We got 12 of you out there. Here's our exam from last time. I graded it. Most of y'all are getting it. Some of y'all are using math software to do it for you, which is at least effort, right? Make sure you know how to do this and not just use the software to do it for you. Some of y'all still need some help. Like, you can't just add 12 plus 12 plus 3, right? These are different y's here, right? They have to have the same exponent and the same variables to be able to add across like that. Honestly, it's kind of weird for volume, but write the polynomial in factored form. So the first thing you want to do is look at the coefficients, right? Each one has at least a 3 in it, right? Like this one here is 3 times 4, y times y times y. This one is 3 times 4 times y times y. This one's a 3y. Out of all of them, they all have a 3 and they all have a y. So that's your GCF. You can always pull out the 3y. And if you want to do this step by step, we would rewrite this guy as 3y times 4y squared, right? There's your 12 and your y cubed. Same thing with the next one. We pull out the 3y because that's our GCF. We still need a 4y, right? There's the 12 and the y squared. And then the last one we would rewrite as 3y times 1. You can see, like I said, everything has a 3 and a y in it. Okay, so you can factor out the 3 and the y, and you're left with this 4y squared plus a 4y plus 1. Okay, now since this thing has a y squared in it, you're going to want to factor this dude. There's two approaches. There's one way I showed y'all, what they called the AC method, or you could recognize this as a perfect square. Remember, a plus b squared is a squared plus 2ab plus b squared. Okay, so if you think of, if you wanted to, if we use that approach, this 4y squared is a perfect square. It's 2y squared, and this 1 here is the same as 1 squared. So what we have here, 2y would be our a, 1 would be our b, and if we can rewrite this in this form, which is, has to have a 2, and then a, whatever a is, our a is 2y, and then our b is 1. Okay, so we've written this to fit that, which means it can be written as a perfect square because this is 4y. 2 times 2 times y is 4y. So this happens to be a perfect square. So because this is the same as this, we can write it like that. So our a is 2y and our b is 1. So that's one way to do it. That's you doing it the way we learned in one section. Let's do this a different way. From here, instead of doing the perfect square thing, because not everything's a perfect square, right? Let's use the other method, the AC method. A is 4, C is 1. And look at our B here. Our B is 4. So we need two numbers that multiply to give us 4, but add to also give us 4. Let's figure out what these two numbers are, because that's going to allow us to rewrite this. About 2 and 2, they multiply to give us 4, and they add to give us 4. So the AC method says to take this 4y and rewrite it as 2y plus 2y. And then we factor by grouping. We treat these as two different groups. So out of the first group, we could pull a 2y out, and that leaves us with a 2y plus 1, right? There's the 4, the y squared, and the 2y. And this is already a 2y plus 1. We want to rewrite whatever's over here as 2y plus 1 times something. Since it's already a 2y plus 1, we'll write it as 1 times 2y plus 1. So we have our 3y, we have a 2y and a 1, and they're both being multiplied by 2y plus 1. Since these are the same, you can rewrite it like this, which is the same thing we got up here. So there's two different approaches to this problem, right? This one just happens to be a perfect square, and we did a perfect square section. This is what we're going to learn in the next section that wasn't required in this course, but this works for everything that's factorable. So really, this section would have been more important because it allows you to factor anything that's factorable. This whole section only applies to if it's a perfect square, if this actually fits this formula. Okay, so this is more important. Remember, this is the AC method. You'll see it again in college algebra. All right, you'll see all of this again in college algebra. Like, yeah, pretty much everything. We're going to do all of the whole class all over again. So here's your quiz. I can tell you that these happen to be perfect squares. All right. So try to use your perfect square formula. I'll write it over here. A plus B squared. A squared plus 2AB plus B squared. Or you can use the AC method. Either one will work. Okay. I like the AC method better because I don't have to recognize this as a perfect square. It's a whole lot of work to see, does this fit this format? Okay, the AC method, either you'll be able to find a P and Q that multiply to give you A and C and add to give you B, or you won't be able to find a P and Q. If you can't find a P and Q that do this, then it's not factorable, right? These do it whichever way you want. We'll work them both ways. Here, and you should be able to do these in 10 minutes. All right. So at 2:20 we'll work these together. All right, class. Let's see here. If we're going to use the perfect square method, first we have to acknowledge that this is a perfect square and this is a perfect square, right? We have the x squared and 81 is 9 squared. So if you recognize these as perfect squares, you ask yourself, well, does this look like that? Because if it does, then this whole thing is a perfect square. So it has a 2, an A, and a B, right? So we put a 2. What is our A here? Our A is X, and our B is 9. So does this equal this? 2 times 9 is 18, times X is 18X. Yes, it does. So because this fits this is a perfect square. We can just say, okay, this is X plus 9 squared. Of course, you could check your work, right? If you have X plus 9 times X plus 9, you have the X squared. You have a 9X. We have another 9X. And we have a 9 times 9, which is the 81. And this adds up to that. All right. The other method is the AC method. All right. Say, or we take A times C. A here is 1. C is 81. I mean, yeah, 81. So 81 times 1 is 81. Our B here is 18. We need two numbers that multiply to give us 81 and add to give us 18. So what could they be? Well, how about 9 and 9, right? They multiply to give us 81 and they add to give us 18. So we could say 18, rewrite 18 as 9 plus 9. And then we group. So out of the first two terms, we could pull an x out. And out of these two terms, we could pull a 9 out. So what do we have here? We have an x and a 9, both multiplied by x plus 9. We have an x and a 9, both multiplied by x plus 9, which is x plus 9 squared. So you can do it either way. Okay. Let's look at the next one here. If you see this and that, and those are both perfect squares, you ask yourself, does this fit this? All right. Well, 36p, that would be 6p squared, and 25, 5 squared. So our A here is 6p, our B is 5. So does the middle match 2AB? Well, here's your A, here's your B. Are these equal? Is this equal to this? 6 times 5 is 30, times 2 is 60, and then a P. So yeah, it matches. So you can just say, okay, this is A plus B squared. And that's it. I should write up here. Equal x plus A squared. Sorry, x plus 9 squared. So down here we have 6p plus 5 squared. So 6p is our A, 5 is our B. And you can check your work, right? Or we could figure out how do we break this up using the AC method. A times C, it's gonna be harder, a lot harder, right? Because what is A times C here? We have 36 times 25, which is 900. And our B is 60. So in this case, the perfect square, it's just boom, boom, right? But this AC method, we need two numbers that multiply to give us 900, but add to give us 60. And there's a whole lot of numbers that multiply to give us 900, right? We could just start picking some. Like we have like 50 and 18, but those add to give us 68, so that's not going to work. How about, and I'm going to divide by 20 and see what we get, because I know 900 is divisible by 20. Like 20 and 45. Is that closer? That's 65. We need 60. These gave us 68. So this is closer. And last time I made this number bigger. Maybe I'll pick a number a little bit bigger than 20 and see what I get. 900 maybe divided by 22. No, that doesn't work. Maybe by 25. 25 and 36. Well, these add up to what? 61. But we need 60. That's still too much. Yeah, let's try 30. Let's try that. 900 divided by 30 is 30, right? We kind of already know that these numbers need to be the same because on these perfect squares, right? On the perfect squares, the numbers were the same every time, right? So that's typically not the case. That only happens for a perfect square. So those multiply to give us 900 and they add to give us 60. That tells us to take the 60p and rewrite it as a 30p plus 30p. And then we can group. So out of the first two terms, let me move this down. Let's see, I can pull out what, a 6 and a p. I still need a 6p. That gives me the 36p squared, and then a 5. That gives me the 30p. And over here, I could pull out a 5. It leaves me with a 6p and a 5, right? There's the 30p and the 25. So I have a 6p and a 5, both multiplied by 6p plus 5. 6p and a 5, both multiplied by 6p plus 5, which is 6p plus 5 squared. Same thing we got up here, right? So if you see these are perfect squares, check and see if this whole thing is by seeing if this can be written as 2 times the a times the b. Because then you can just do this in one step. Boom. Right? If you don't have perfect squares here, and this is not 1, right? If you have a number there, this is typically what you have to resort to. So that, of course, that, or you just type it into some software and it tells you the answer, right? Okay, so that's it for today's quiz. We've been going through and doing review. We made it through 6.3. We are at 6.4. And, oh yeah, instead of pulling them out of here, were we pulling them out of here or were we going through the homework itself? I can't remember. I think we're going through the homework. Let's see. This button. Yeah, we'll go to the assignments. There we go. And 6.4. Wonder if I hit preview. No, that's not the right button. Just click on it. No, that's not the right button either. Hold on. I can't hear anything. Where's my volume? Hold on a second. I hear somebody talking, but I can't hear you. I remember now. Go to content. There we go. Now I'll pick a few problems then. Okay, so this one is about proportion. Okay. This is good to know stuff. All right, so Evelyn won an election by a ratio of 5 to 3. If she received 5,625 votes, how many votes did her opponent receive? So for every 5 for her, there was 3. Let's assume the opponent is a him, just so I could say him. All right. So she received this many votes. So this would be 5,625 for her. How many for him? Now, you'll understand the setup here. The ratio has to hold. So we want to know what X is here. So if I'd have been smart, I'd have written this the other way around. I'd have written this as, I want to know how many are for him when there was this many for her. And I know there's 3 for him for every 5 for her, right? I'd have written the problem down like this in the first place. But all I did here was flip these over, right? I took the reciprocal of both sides, and I wrote this side first, simply because we like to have the X on the left side, okay? And then from here, since we're trying to get the X, let's see, how can I do this? It's divided by this thing, so let's multiply both sides by 5,625 her. 5,625 her. So those cancel. There's X him equals, so over here, the hers cancel. All I need to do is multiply 3 times 5. Let's see. 3 times 5,625. Divide by 5. And I get 3,375 hymns. Of course, I can divide both sides by hymn. If you want, right? And so X is 3,375. Right? So you take a final exam, you want to write things nicely, put a box around your answer, right? This isn't the nicest I could do, but it'll work. Some of my other classes, some students turn in stuff that looks like, I don't know, it looks like they scribbled stuff down on like a wrinkled napkin. You know, it's like something I'd expect from like a war correspondent who snuck me a note through a spy, you know, from across enemy lines or something, you know. It's just a final exam, right? You're not hiding out, you know, in Iran or something with people shooting at you. So try to make it easily gradable, and let me follow your train of thought. Now, if you just write this down, you get no credit, okay? None, because you didn't do anything except look the answer up, all right? Let's look at another one. These are good to do. We'll do more of these. So let's look at like 26. These are important. A lot of mathematics hinges upon just basic ratios. Eric bought $910 Canadian with 875 American. At this rate, how many Canadian dollars can he buy with 150 American? So in the last problem, I started with this information and made a ratio, right? How about we start with what we're looking for? How many Canadian dollars can he buy? X Canadian, right? When I have 150 American. We're looking at the ratio of Canadian to American, and over here they give us the ratio of Canadian to American. I see that 910 Canadian, 875 American. I'll just use the dollar sign for American. Okay, so that way the X is really where I want it to be. So I can be like, okay, multiply both sides by $150. The American dollars cancel. And I get what, 910 divided by 875. 910 divided by 875 is 1.04 Canadian. So divide both sides Canadian, X is 1.04. This is acceptable work here, okay? I mean, it didn't go into all of this, right? But this actually has all the same math, okay? This showed every thought that I had in my head along the way. We could do this a slightly different way. Think about unit conversion. When we say this, we bought this with that, we're saying that 910 Canadian is the same thing as 875 American. So I want to take $150 American and I want to convert it to Canadian. And here is my conversion. $150 is the same as 150 times 1. And I'll use a smart 1. I'll rewrite this number 1. I want to get rid of dollars and I want Canadian. Well, $875 is the same as 910 Canadian. This is the number 1. The dollars cancel and You can see I have the same numbers up here. 150 times 910 divided by 875. 150 times 910 divided by 875. I'm going to get 104. We still have units of Canadian. So this is using unit conversion, right? And this is using proportions. You could also done it using percentages, but then you end up usually rounding incorrectly. All right. Let's see. This is 26. Let's try 38 here. Mitch mixes 5 parts white paint to 8 parts blue paint. Can we do this one? Like we did this one. If he has 4 quarts of white paint, how much blue paint will he need? So let's let X be the blue. And we have 4 of white. Okay. So here's our ratio. We're comparing blue to white. So we need 8 blue for every 5 white. So we just need to solve for X. So let's multiply to get the X. Let's get rid of this 4 white. So that goes away. You can see white cancels. So I have X blue. So what is this? 8 times 4 divided by 5. 8 times 4 divided by 5. 6.4. Blue. Of course, I could divide both sides by blue. And X is 6.4. Right? That's how many quarts of blue paint we would need. Or I could do the unit conversion thing. I could say, okay, 5 white is equivalent to 8 blue. I want to take 4 white and convert it by multiplying it by a smart 1. I want to get rid of white, and I want blue. And I know that 5 white is the same as 8 blue. And I'll get 6.4 blue. So I have units of blue. So 4 white is equivalent to 6.4 blue. I know it sounds kind of weird, right? Up here in the dollar thing, you know, it's like, yes, this is equivalent to that. Here it doesn't sound right. Like 5 quarts of white is equivalent to 8 quarts blue. It's abstract, right? But mathematically, that's what we're saying. $38. 45 here. All right, we have some solve for X and Y. Okay. So this is going to be proportions again. Since these triangles are similar, they're exactly the same except one's bigger than the other. And we can look at ratios. The ratio of X to 8 has to be the ratio of 10.5 to 28, especially considering they're all yards, right? So X is 10.5 over 28 times 8, right? You're just multiplying both sides by 8. Boop. We can do the same thing for Y. Let's say Y over 28 is the same as 9 over 8. So y is 9/8 times 28. Multiply both sides by 28. Okay. I want to do one where they have different units. This one is the same as the last one. It's all meters, but solve for x and y. Let's see. X over 8 has to be the same as 1 over 6. So for x is 1/6 times 8. Notice if we wrote the units here, we have x meters over 8 meters equals 1 meter over 6 meters. The meters all cancel out. Okay. Look at y. Y over 8 has to be the same as 2 over 6. So y is going to be 2/6 times 8. And then you just simplify, right? You can do the simplification here. 8 is 2 times 2 times 2. 6 is 2 times 3. 2 times 2 times 2 is 8 thirds, right? For those of y'all who still need some practice with fractions, right? This one, 8 is 2 times 4. I'm not even going to bother writing the 4 as a 2 times 2 because I know that 6 is 2 times 3. So there's no need to break that into 2 times 2 and then multiply it back together again to get 4. There we go. So we want to solve for x and y. A Great Cookie Company has a sign on the front of its store as shown in the figure. The company would like to put the same shape sign on the back, but with dimensions half as large. Okay. Find the lengths x and y. So half as large. We need to have x has to be half of 2, which would be 1, and y needs to be half of 4, which is 2, right? Notice this is less than half the area of this. Half the area of this guy would be this big. So the area, half the area is bigger than that. If you take both of these and shrink them by half, the area is 1/4. This is basically, the area is 1/4, but the lengths of both decreased by half. So it's a relationship that's important to recognize, right? Area is length times width, right? So if you replace length with half and width with half, you got length times width over 4. That's your old area over 4, right? I'll call this area prime for the second area, or I should call it A1 and A2. Let's see, 4. In a recent year, the rate of prostate disease in U.S. men was 114 cases per 1,000 men. That's over 10%. At the same time, a certain state had approximately 1.7 million men. Use a calculator to find out how many men in this state would be expected to have prostate disease. So we'll say X prostate disease out of this many million men, they say there's 114 prostate out of 1,000 men. So if we're solving for x, multiply both sides by 1.7 million men. That cancels that. The men cancel out. We're left with prostate. So, and you can divide both sides by prostate. So x is equal to this times this divided by that. Of course, we could go 3 zeros. So x is 114 times 1700. Whatever that is, you plug it in your calculator. I want to show you something. Let's say, let's look at this one again. What if this, instead of meters, was inches? All right. The problem would be exactly the same. To solve for x, I'd have x inches over 8 inches is the same as 1 meter over 6 meters. The inches and the meters cancel out. You have exactly the same thing. Okay. So even though they drew this bigger, what if it was actually smaller? Because we're talking about inches. Okay. So as long as all the units are over here are the same and all the units are over here are the same, right, the ratios will still hold. All right, so 6.62. Except for this section, let's see. Give it a red check mark. That's 6.4. Look at 7.1. Okay, how do I get to 7.1? The material gets harder, I'll work more and more problems. These are easy, right? Percents to fraction. These are more tedious than anything. So we want to change this percent to a fraction, right? Well, 3/4 is 0.75, right? So we're looking at that percent. All right, so since we got rid of that fraction, got it as a decimal, percent means per century. Dividing by 100 means move the decimal to the left by 2. All right, there's another one. All right, is equal to 84.9%, which means move the decimal to the left twice. And 3, and let's look at 38. Oh, another one. So we could put that over here. All right, we have 0.29%. Move the decimal to the left twice. 38. Let's look at 45. Same thing. that one over here. All right, we're changing from a decimal to a percent. So this is different, right? 0.93. We need to write it as something over 100. This would be 93 over 100, which gives me 93%, right? You move the decimal to the right twice. Or if you're uncertain, you could be like, I need 100 on the bottom, right? But you can't have 100 on the bottom. Well, let me do it right a little different. I need 100 on the bottom. I can't just put one on the bottom unless I put one on the top too, right? This is the number one. Multiplying 0.93 times the number one. So I keep the 100 on the bottom, and 0.93 times 100 moves the decimal to the right twice. So it's using your smart one knowledge. Right? There's any number of ways to think about these things. Right? If you can't remember just move the decimal, resort to more fundamental math, and it'll remind you. Right? It can get confusing. Like, am I going from a decimal to a percent, or a percent to a decimal, or a fraction to a decimal? Right? For all of you know who got this down, it seems simple, but it's not, you know. So this is already, there's your percent. Right? What's left? 41. Okay, this one's going to be a little more tedious. When I look at this, I'm like, I wish I could turn that into 100, but there's no number I can multiply 9 by to turn it into 100, right? So I kind of just need to turn this into a decimal. Now you could do your division over here, but y'all are going to have a calculator in hand, right? In the final. So divide 17 by 9, and you're going to get 1.88888, the bar over it. So to turn this into a percent, I need to have 100 on the bottom. All right, so I'm multiplying it by a smart one. So I have 1.8 bar over 100. Keep the 100 on the bottom. If I multiply this by 100, I'm moving the decimal, to the right twice. So 1, 2, since it's just a whole bunch of 8s. All right, move the decimal to the right twice. So this is 188.888888%. All right, remember 1 over 100. This is just shortcut notation for writing 1 over 100. There's the 1 over 100. Okay. Go ahead and do the last two. These don't take long. Complete a table. Nah, okay. So my daughter is 1/4 Hispanic, but I swear sometimes she sounds like she's 5/4 hillbilly. The other day in the backyard, she stepped in some dog poop. It's a big old pile. She got stuck in it. She starts yelling, "Daddy, Daddy, help, help, help." I'm like, oh my God, I raised a little hillbilly. Hopefully I can work that accent out of her. Okay, this is gonna be a lot of work. Let's see. 82% as a decimal, right? Well, 82% is 82% is 0.82. So boom, 0.82. How do we write this as a fraction? Well, we already did. It's 82 out of 100, right? But they probably want us to simplify it, right? So both of these are divisible by 2. So I look at that, right? Um, and I think 41 is prime, so I'd write 41 out of 50. I mean, this will work, but technically it is a fraction. They didn't say simplify. Okay. 1/3, y'all know that is 0.33333333, right? 0.333333, right, is to get that 100 on the bottom. Multiplying this by 100 moves the decimal to the right twice. All right, so did I do that right? 1, 1, 2, yeah. We have 33.3%. 0.8, this is the easy one, right? All right, 0.8 is 0.8. Got to get that percent on the bottom, moving the decimal to the right twice. We got an 80%. All right, and as a fraction, you already have it right here. You can just go boom, boom, 8 out of 10. Okay. Look at, go ahead and do the last problem too. I'm sure it's another table here. Okay, let's see here. Let's fill in this table. Happy little table here. 95%. Well, that's 95 out of 100, right? Which is 0.95. Well, we already have it as a fraction. Let's see, this is 5 times 19 over 5 times 20. You see, oh, this is 19 out of 20. 1/3. Didn't we just do 1/3? Yeah, we just did 1/3. All right. Don't need to do it again. And we did 0.8. All right, so we're done with that one. And let's see, that finishes up with 7.1. Boom. Look at 10.1 now. Jumping all over this book. Let's see. Okay. Content. Let's look at, why are these all the same? I don't get it. I'll pick one of them. This is the same problem, but it throws different numbers in there each time. All right. Identify the following as either an expression or an equation. Well, it's both. I guess an expression would be like 7y plus 3. That would be an expression. So we would call this an equation. This is just terminology. I'm not going to ask you anything stupid like that. That's a stupid question. Let's go down here and look at something more interesting. Maybe this one. Solve the equation. Okay. Well, if we subtract 6 from both sides, we have a equals -5. All right, check your answer. Well, if I replace a with -5 and add 6, I get 1, which is the other side of the equation. These are fairly simple here. Let's go down a little ways. some that are a little bit more difficult. All right, you should be able to look at this and say, obviously x has to be 0 because 3 times 0 is 0. All right, so the solution set would be 0, right? I'm not even going to write that one down. The simplest of equations to solve. All right, this one at least it has a fraction in it. Let's write this one down here. All right, if I had this, the hardest or trickiest problems were always the last two questions of each section. Yeah, they always like to throw in tricky Trickerton at the end, right? So if I want to get A by itself, I need to get rid of this. And whatever I do to this side, I have to do to the other side. So to get rid of the 5, I'd multiply by 5. To get rid of this 4, I'd divide by 4. And I have to do the same thing to both sides to keep it in balance. See, the 5s go away, the 4s go away. This is all just the number 1. So A is minus 5, right? I mean, that's the ugliest way to write this. Like if I was going to write this all pretty, right, I'd be like this, if and only if, if and only if this, if and only if A equals minus 5, and then box my answer, right? That's how I would write it out nicely, doing it step by step. That's what, 45, 46. Let's do solve the equation. All right, there's 2 of them here. So for A, x minus 7 equals minus 5. I need to get the x by itself. I'm going to get rid of this 7. So x is 12. B, I have to get rid of this minus 7. I'll divide both sides by a minus 7. That goes away. Those would cancel. X is 5/7. You want to be able to just look at this and go, I need to move this down here. You should be able to look at that and write down x is 5/7. All right, you should be able to look at this and write down x is equal to 12 at this point. These all seem to be the same thing. That's okay, we'll do the last one. All right, we got some cubes going on. Determine if the equation is linear in one variable. Well, there's one variable, but you got a p cubed here, so it's no. If you graph something, a p squared, this would be like x squared, right? A straight line would be like x. This would be like an x cubed. 1, 2, 3. This would be like an x to the 4th. 1, 2, 3, 4. Right? Will these go on forever? All right, so that's how polynomials work. The higher the power, the highest order, right? So if you had something like 3x to the 4th plus 2x squared plus 1, you look at the highest power, that tells you how many wiggles there are. All right, so this one's just a simple definition. How about we solve? Let's solve for q. First thing you want to do is factor. Wait, no, wait, this is a p and that one's a q. So this one is 2 variables Sorry, my dyslexia was kicking in. So this is way not true. It's one, it's two variables, and it's not linear in either variable. All right. Let's see here. We could rearrange this. We could write q equals negative 6p cubed. So if we graphed this, right, if we called qy and px, right, you can rename stuff, right, and call this a function, this thing cubed would look like that. So it's not linear at all, okay? So we can't really solve this. The solutions are the graph, right? That's what the graph would be, okay? The graph represents all the possible solutions, all right? Like you could have 0 and 0. So technically, this thing should look more like that. We'll go through the origin, the point 0, 0. That's one solution, because if I replace p with 0 and q with 0, 0 plus 0 equals 0. Okay. I don't know if the rest of it looks like that. It's just a guess, but it goes through the origin. Let's see, I could pick another one. If I pick p to be 1, q would have to be a minus 6. So 1 minus 6 would be a solution to this equation. So p is 1 and q is minus 6. So if I went over 1, I have to go down minus 6, so that would be 1 minus 6, right? Then every other point on this graph should satisfy that equation. But again, they're just asking you how many variables. This is a scoring section. So this is 10.1, vocabulary and simple solving. Let's see. Oh, I forgot to look what the next section, 10.2 probably. 10.2, yeah, let's look at 10.2 here. 10.2. Content. Solve. Okay. All right. We can combine like terms. I was going to write this out nicely. 8b minus 7b gives me 1v. 8 minus 3 is 5. And if I subtract 3 from both sides, 5 minus 3 is 2. Now this one at least has some parentheses in it. All right. The goal is to get all the p's together. And there's only a single p here. So how do we get to that? All right. Well, we could get rid of these parentheses. If I distribute the 5, I would get 10p plus 10. And I have a minus 2 equals 3. Well, I got rid of the parentheses. 10 minus 2 is 8. I'm still trying to get to the p here. How about we get rid of that? All right, let's get rid of the 8. And I have a 10p equals minus 5. So now to get to the p, divide both sides by 10. Right? So this would be a negative 1/2. Do more of these. Okay. let's see here. We have t's in two different places, so we need to get all the t's together. First, let's get rid of these parentheses. If I distribute this 12, I got a 12t and a 24. I got a 5t minus 50 and this lingering 18. So let's get all the t's on the left-hand side. If I take 5t from both sides, that goes away. That would give me 7t plus 24. And if I combine these, I got a negative 32. And now I'm still aiming to get this t by itself. Let's get rid of this 24. I have a 7t, whatever this is, 56. Now to get the t, divide both sides by 7. Let's see, 56 is what? 9 times 7? 7 times 3 would be 21. No, it's not right. Is it 8 times 7? Can't remember my multiplication table anymore. Yeah. So I got negative 8. Of course, you could check your work by plugging the minus 8 in and making sure both sides of the equation are equal. Right? Just like we could have checked up here by plugging in minus 1/2. 2 times a minus half would be a minus 1. Plus 2 is 3. All right. No, minus 1 plus 2 would be 1 times 5. Is 5. 5 minus 2 is 3. So, yeah. So it's 47, 48. How many got here? Well, now they've thrown in some decimals. That's okay. We have calculators and stuff, right? I mean, you could just type this into some software, right? Solve this, and it would tell you the answer, right? But that won't get you credit on the final. Of course, you can use that to check your work, right? All right, we want m. We need to gather our m's. So let's get rid of these parentheses. 2 times 0.1 would be 0.2. 2 times 0.7 would be 1.4. 1.4. Right? And we got the 3.2 m plus 0.16. So let's get the m's together. Since this one's bigger, we'll get the m's on the right side. So I'll subtract 0.2 m from both sides. So that'll go away. I'm left with negative 1.4. 3.2 minus 0.2 gives me 3. Right? So I have to get the m by itself. Now I've collected them all here. I'll get rid of this 0.16 from both sides. That goes away. So let's see. Use my calculator here. 1.4 plus 0.16 is 1.56 negative 3m. So divide both sides by 3 to get that m by itself. And that gives me 0.52 with the minus. 758. Get on there. Go down a couple here. All right, we need to get all our y's together. This one, you can just look at it and go minus 2y minus 2y, right? Those go away. This equation is the same thing as 5 equals 5, right? Because I can add 2y to both sides. The y's disappear, okay? And that's the same thing as saying 0 equals 0 or 1 equals 1, right? X is any real number at all. Any real number. Plug in any number you want here. Pick 7. 5 minus 2 times 7 is 5 minus 14, which is negative 9. And now for the other side, negative 2 times 7 plus 5. Negative 14 plus 5 is negative 9. Those are equal. Plug in any number you want for y, and the equation is true. Right? So instead of just being one number, this one has an infinite number of solutions. This is what we would call a tautology. Okay? It's always true. It's stating something that's always true. An equation that that is an identity has infinitely many solutions. That's what we just saw. It was an identity. Okay? You'll see those more in mathematics. They are very, very useful. Something is identically equal to something else. Something like, let's see, with an identity. Something that's always true. 3x over 4 is equal to 6x over 8. Right? It's true for any x. Okay? X is any real number. This is always true. So you can always replace a 3x over 4 with a 6x over 8. Of course, later on, like when you get into pre-cal, you'll be like, I can replace sine squared theta with cosine squared theta with the number 1, no matter what number of theta is. For any number theta, this is always equal to the number 1. So that's a trigonometric identity, right? And there will be a lot of them. Like you'll be able to say, okay, cosine of 2 theta is the same thing as cosine squared of theta minus sine squared of theta. This is an identity because no matter what number you plug in for theta, this is equal to that. So anytime you see this, you can replace it with that. Anytime you see this, you can replace it with that. Or you subtract cosine squared from both sides. You can always replace this with this, because this statement is the same thing as that one. All I did was move this over. All right? So you're going to learn lots and lots of identities, and it's an important thing to know. What is this? Oh, a new problem. Suppose the solution set for x in the equation is 6. All right, so what they're saying here is x is 6. Replace x with 6. So what is a? Subtract 6 from both sides. A would have to be a negative 17. That was 93, 94. I think we've seen enough of this. I guess we could do one more. Suppose the solution set for x is 8. What they're saying is x is 8. So if x is 8, and we want to know what a is 44 divided by 8, right? Divide both sides by 8. Now you could simplify this, right? 44 is 2 times 22. 22 is 2 times 11. 8 is 2 times 2 times 2. So we have 11 halves. The box. And that's it for 10.2. Look at 10.3. Okay, let's see. All right, more of the same, but they just threw in a bunch of fractions to make it ugly. Same process. All right, let's see. Solve for y. We have y's in 2 different places. And we've got parentheses. You know what? All these fractions suck. Let's get rid of the fractions. Let's see. There's a 12, a 4, a 6, and a 4. You know what? If I multiplied everything by 12, since 6 and 4 and 12 all divide into 12, I would get something completely different. 12 over 6. 12 divided by 6 is 2. 12 over 4 is 3. 12 over 6 is 2. 12 over 12 is 1. That's the first thing I do. Get rid of all those fractions because they suck. Now we just want to get the y's together, but this parenthesis is in the way. So let's distribute. That gives us a 4y and a minus 12. All right, let's get the y's together. I'll subtract the 2y from both sides. Oop. 4y minus 2y is a 2y. Combine this 12 and this 3 to give me a 15. I still want the y by itself, so let's get this 15 out of the way. That gives me a 2y. 7 and 15 is 22. Get that 2 out of the way. 22 divided by 2 is 11. That's how I would approach that. 23. Oh, this one has fractions again. I bet I can get rid of those fractions. Same way I got rid of them last time. Let's multiply everything by 12. Both sides. 12 over 12 is 1. 12 over 4 is 3. Oh, I got ends here and there. Let's get rid of these parentheses. 3 times 2 is 6. 3 times 9 is 27. And let's get all the ends together. I have more of them over here, so let's move them all to the right. Over 45. 6 minus 4 is 2. I want the n. Let's get rid of this 27 here. 45 minus 27, and what is that? 18, I think. Let's cancel. Divide both sides by 2. N is 9. There's more fractions. Okay. We can get rid of these fractions again. Multiply everything by 3. 3 over 3 is 1. I have a minus. Gotta be careful here. 3 over 3 is 1 again. So I have a 3n minus 2. Now, why am I putting these parentheses here? Because I'm subtracting this whole thing, right? So I have a negative 3n and a negative negative 2. All right. So this is an instance where I'm putting parentheses in. 3 times negative 2. Okay. So be careful here, right? I could rewrite this as plus 3n plus 2 over 3. All right. This is a negative, negative. We're distributing this. When I put the parenthesis, the minus like that, it means the whole thing is negative. Okay. So be careful, right? And this would be, sorry, negative 3n, a negative 3n, and a negative negative 2, a negative 3n, and a negative negative 2. So we have a negative 3n and a minus minus 2. Okay. 6n minus 3n, 3n, 1 and 2 is 3. Let's get the n by itself. Let's get rid of this 3 here. So divide both sides by 3. We have a negative 3. Okay. Maybe we should do all of these. Some subtleties. There's more fractions. Get rid of the fractions. I mean, you don't have to get rid of the fractions. You could do everything with fractions. It just sucks. What's the smallest number both 4 and 7 divide into? Fortunately, I think it's 28. Right? 7 doesn't divide into 8 or 12 or 16 or 20 or 24. Right? Basically, we're multiplying everything by 7 and a 4. Okay. I could write it like that. Multiply everything by a 7 and a 4. So if I did that, the 7 over the 7 cancel. I'm basically multiplying everything here by 4. 4 times 3 is 12. 4 times 5 is 20. Those 7s cancel, right? Now for this guy, all right, remember this is like parentheses here. The 4 over the 4 cancels, so I'm basically multiplying everything here by 7. 7 times 3 is 21. 7 times 12 is Bart. 80, what, 80, I don't remember. 12 times 7, 84. There we go. And then for the 5, we have to multiply it by both. So 5 times 28 is 140. Let's get rid of these parentheses. We have negative 21q and a positive 84. Now we can get our q's together. This would be what, a negative 9q. Combine these, that's 20 and 84 is 104. So to get the q by itself, let's get rid of the 104. That gives me 36. The q is 36 over negative 9, right? The minus, and 9 times 4, negative 4. And so these are a little bit more difficult. The hardest part here is distributing that minus across, okay? kind of technical. 35, 36. Solve the equation. Okay, all right, let's see, here's our x. Let's add 1.5 to both sides. So that gives us 9.2x equals, what is this? 53, 54, 55.2, right? 7 and 5 is 12. There we go. Now divide both sides by 9.2 and plug this into your calculator if you want. 55.2 divided by 9.2, which is 6. You know, it's not necessary, but if you wanted to get rid of the decimals, if you multiplied everything by 100, that would move the decimal to the right twice. So you'd be looking at 8b plus 60 equals 28b minus 2080, right? You could do that. All right, is it right one, twice? Yeah. You could do that, and then you don't have to deal with decimals, right? But there's no need to, right? You don't have to do that. Instead, just work with the decimals here. Let's get all the b's over here. So if I subtract 0.08b from both sides, that goes away. So I got 0.28 minus 0.08 would be 0.2, right? We want to get the b by itself, so we can add 20.8 to both sides, but that goes away. 20.8 and 0.6 is what, 21.4. So the b is 21.4 divided by 0.2. Right, dividing by that. Then you use your calculator. Be like 21.4 divided by 0.2, and you get 107, right? I was just showing you that you don't have to work with the decimals, but you're going to end up using calculators anyways. Why not just use the decimal? 39 and 40. There we go. Solve the equation. Select all real numbers if applicable. I can tell you right now, the b's do not fall out of this equation, right? So they have decimals and fractions. That's lame. Let's get rid of the fractions. All right, decimals are easy. Fractions suck. All right. 10 is the smallest number that divides both of these. If I multiply everything by 10, 10 over 2 is 5. 10 times 0.6 is 6. 10 times 0.7 is 7. 10 over 5 is 2. Times 4 is 8. That was nice. That got rid of the decimals and the fractions. Awesome. Okay, now we need to get our b's all together. So let's add 8b to both sides. That gives us 13b plus 6 equals minus 7. We want our b by ourselves, so let's get the 6 out of the way. And now we want the b by itself, so divide both sides by that. You can see that b is -1. Hard to look at this and go, obviously b is -1, but if you plug it in here and plug it in there, you will see that that's what it is, right? 0.6 minus a half. A half is 0.5. 0.6 minus 0.5 would be 0.1. Over here, if b is -1, we would have 4/5. Well, 4/5 is 0.8 minus 0.7 is 0.1. So you could do a check in your head. You want to be able to do basic decimals and fractions in your head. You're going to be required to do that, eventually. So practice it while you're doing your homework. Don't just type solve into the software and get the answer and write it down. You need to do this, and you need to practice doing the basic arithmetic in your head, because you're going to need that skill. If y'all are STEM majors, this is the basics of just thought itself, right? You need to be able to do that in your head reflexively. Okay, let's see. It's about 3:40. Let's do this. Let's go back. Okay, let's go to 14.5. Content. There's lots of problems in 14.5. That's good. Let me see. I forget which one I picked last time. This is going to be for your exam today. So if we've done this one, let me know. I'm going to give you the same. This looks like something we've done. We've done this. So let's look at a different one. 52. Meh, that'll work. This is the daily exam. 25. Factor completely. Boop. This one. Oh, that's a good one. Factor completely. Now, a big hint is that this section, sorry about that. This section is about perfect squares. These happen to be perfect squares. This is a perfect square, that's a perfect square, and I'll bet you that will match your pattern for perfect square, right? But you can also use the AC method, okay? That's it for today, folks. I know it's kind of early, but I think we have plenty of time to do all the homework and from the whole semester here before the final exam. So that'll be it for today. I will see y'all on Tuesday. Keep working on the Alex homework. If you've done it all, keep studying. Okay. Remember, practice makes perfect.
Thank you, sir.
You're welcome.